Here in the College of Engineering at UTSA, we give our students the opportunity to be part of something really amazing. They have the ability to go into the laboratories in the engineering school and conduct research, taking the knowledge that they have gained in classrooms and apply it to research. Not just any research focusing on real-world problems, and the students can find solutions that will impact the world. Even as sophomores and freshmen, we give them the tools and the foundation so that they can work alongside their professors in the laboratories as well as in labs in the industry.
I am Jeanette Oruch de Leon. I'm a lecturer in the Mechanical Engineering Department here at UTSA, and I teach the Measurements and Instrumentation course. We consider it basically the course where students start to get a gist and a feel for experimental methods, experimental techniques that they'll hopefully start to incorporate in more complex research. We try to guide them through the data acquisition procedures. So it's not really only about using the cool technology, but then being able to take the concepts and the processes and the methods of operations and then being able to apply those to whatever we get thrown at us.
My name is Joaquin Obrado. I'm a master's student here at UTSA studying electrical engineering. Over the summer, I had an opportunity to work for NASA at the Marshall Space Flight Center. Over there, I learned about space debris and how a huge problem it is for manned missions in orbit right now. So I'm currently working on just identification and rendezvous procedures for finding a debris, finding some target, and figuring out the best path to get there.
Our labs here in the College of Engineering are equipped with cutting-edge technology, and this gives our students a great advantage. But we just don't leave the students up to their own devices. Our professors in the College of Engineering work closely with the students and help them understand the fundamentals and the principles behind all the methods and techniques that they use. And this gives the students the ability to design their own experiments and research.
I'm Dr. Louis Mans. I work as a lecturer and teach a course in hydraulic systems design, which is open channel hydraulics, which deals with the ability to design channels for stormwater flow, for river flow, for culverts, for drainage.
It's really cool that the university have this kind of equipment to provide their students with, because it just gives them an extra edge over the other students in other universities. Just going over your textbook and learning it's not enough. You really want to see what's going on, and for example, using this flume, being able to see what the water is doing over that weir is just unique. With the flume, we could be able to play with it and really come out with several conclusions and outcomes of this lab.
I'm Brent Nowak, an associate professor in the Mechanical Engineering Department at the University of Texas at San Antonio. We're in the Robotics and Intelligent Machines lab where I do my research, and I bring some of this research into the classroom at the undergraduate level. Behind me are two serial manipulators. These are robot arms that are typically used in manufacturing. Robots fall into a category known as mechatronics, and here at UTSA we teach a project-based learning class in mechatronics where the students merge mechanical engineering, electrical engineering, and software, and they actually design, develop, build, and test and demonstrate intelligent devices. Ultimately, this work, when it gets out into industry and on your career afterwards, you can go into advanced research, you can do autonomous underwater vehicles that explore for archaeological factors, you can help the world solve its energy problems with an intelligent grid, or you could develop medical devices, all of that from mechanical engineering.
The engineering students at UTSA are given the opportunity to work closely with the professors in research labs, and this gives them the chance to further develop the engineering skill sets even outside the classroom. It puts them in a position early on in their college careers to work in research labs on real-life problems that will have worldwide impact.
My name is Brenda Marchand. I'm a sophomore here at UTSA, and I've had the opportunity to work with Dr. Fanol here in the Vascular Biomechanics and Biofluids Lab, working with an outside company to do mechanical testing of polymer films for their future use in wound treatment or for the treatment of soldiers in combat. It's really good to know that my research here at UTSA is not just for a class project. It's going to have a greater impact on not just the city of San Antonio, but other people worldwide. My research is only the initial part, but once this is done, we hope that these polymer strips can better help wounded soldiers in combat or burn victims.
The engineering labs here at UTSA offer benefits to all our students, from undergraduates to PhD candidates. And not just students, we offer benefits to the whole community, because the research we perform focuses on real-life problems, and we look to finding real-life solutions that will impact not just a local community, but also impact globally. That is what we do at UTSA, and that is what we're so proud of.